All right, so this is another clip on balancing equations. If you're struggling on this one, this is just another, redo of the explanation that I gave in class. So I'm just going to do a couple practice problems with you, just at different types, and then if you're still having problems, email me. So the first thing that you do is for every problem, you just divide it into two sides. So your left side and your right side. The left side is always going to be the reactants, and then the right side is always going to be the products. So what we're doing is making sure that the reactant side is the same, whoops, as the product side. I'm going to move that up because we'll see, why in a second. So everything on the left side should be equal to the right side in terms of each element. So the next step is you've got how many different elements in here? You have two. So you have calcium and oxygen. So you write them down here, and then you take your totals of how many calciums you have. So if there's no number after the calcium, then that means you have one. You have two oxygens because there's a two there. So then you go over to the other side, and then you take total of these calciums and oxygens. So you got one of each because there's no numbers, and there you go. So the next step is you're not trying to get all of these to be the same number. Okay, that's not the goal. Sometimes that happens, but that's not the goal. It's just by coincidence. All you're trying to do is get each element on each side to be the same. So you want the same number of calciums on the left side as you have on the right. And the same with the oxygens. So here's how we do this. The rule of the game is you can't add elements if it's not written as a single element. So let's look at our problem. If we have an oxygen that's got one and we want to get up to two, how do you get there? You can't just add another oxygen because that doesn't fit anywhere. If you drew the bonds for this, you wouldn't fit it anywhere. So the only way you can get more oxygen on this side is you have to add the way it's attached. So if it's attached to a calcium, you have to add it with the calcium. So long story short, however the compound is written, you can add more of it, but you can't just add individual elements. Okay? So I add a CaO, and now I have two oxygens because I have one, two. But now I also have two calciums as well, so I have to retotal that. So I got one, two calciums now, so that's two. And let's get rid of these numbers to avoid any confusion. So calcium's good, or oxygen's good, calcium's not. So calcium over here only has one element. So I need more calcium, and since calcium is written by itself in this side, I can add it the way it is. So I just put a calcium, and then I get two calciums. And then my totals, ta-da, are equal. So that means I'm set. So what do I put in these boxes here? The boxes hold what's called a coefficient, which is the large number that you multiply your current equation by to get it balanced, okay? The coefficient is not the number down here necessarily. It's just what you multiply up here to get to the total down here. So the other way to look at it is you just write the symbol how many times it's written. So if calcium is written twice here, I put a 2. If oxygen is written once, I put a 1. If calcium oxide is written twice, I put a 2. And voila, you're done. So let me do one that's got 2 products and 2 reactants. So let's try this guy. Okay, so this guy, what I'm going to do is, same thing, divide it in half. Okay, take stock. Copper, Cu's got 2 right there. It's got 1, and I've got 1 carbon. On the right side, I've got 1 copper, 2 oxygens, and 1 carbon. So the only thing that's balanced right now is the carbon. So all I got to do is get to work on the copper on the right side. So I'm going to add another copper up here to get to 2. All right, so that looks good. But now my oxygen is out of whack over here. So I've got 1 on the left, and I have 2 on the right. so I need more oxygen on the left. Since oxygen is written with 2 coppers here, and that's the only way I can add it, so I write Cu2O. And now I've got 2 oxygens, but now I've got 2 coppers and 2 more coppers, which gets me a total of 4. Okay, so now oxygen looks good, carbon looks good, copper does not. So what I can do with the copper is it's by itself on this side, which means I can add just copper, because that's the way it's written. So I do this and this. And now I've got 4 coppers. So I am balanced. This is equal, and this is equal. So now what I got to do is write my coefficients. This is written twice, so I write a coefficient of 2. This is written once, so I write a coefficient of 1. This is written 4 times, so I write a coefficient of 4. And this is written once, so I write a coefficient of 1. 2, 1, 4, 1. That's it.